So let's start with this understanding the principle of horizontal sextant angle, why we are doing. So these are two lighthouses and this is the position circle of the vessel. Suppose our ship's position is here. Okay. So if the ship is here, it will see these lighthouses at these bearings. And this will be our horizontal sextant angle. Now let's see what is the principle. So the principle is that if you draw from any two external points, if you draw an angle on the circumference of the circle, so these are two external points, our lighthouse, and from here, if you draw an angle at the center of the at the circumference of the circle, so it will be our circumference, and from here, this angle is A, and then if you draw an angle at the center of the circle from the same points, so from these 2 points again you draw the angle of the at the center of the circle. So suppose the center is this point C, and from at this point we draw an angle at the uh, same external points. So this angle will be 2 alpha, that is twice the angle of alpha which is subtended at the circumference. So this is our principle. Angle at the center will be twice the angle at the circumference. Now let us see how do we use this principle for plotting the horizontal sextant angle. So now what do? We join these two lighthouses and we need to get the angle which is subtended, this base angle. Now this, both the base angles will be equal because this is an isosceles triangle, because we are plotting from the same external points and going to the same center radius of the circle. So it has to be, these sides have to be equal, and therefore these base angles have to be equal. Since these base angles have to be equal, let's see this, say this angle is B, bravo. So bravo plus bravo is 2 bravo. And what is the sum of this angle? It will, total sum of the triangle is 180. So 180 minus 2 alpha is your bravo plus bravo. So bravo plus bravo is equals to 180 minus 2 alpha. So 2 bravo is equals to 290 minus alpha. So bravo is equals to 90 minus alpha. So this bravo is always 90 minus alpha, this angle. So if you have the horizontal sextant angle, you can plot this base angle. So this alpha is our horizontal sextant angle, and you can plot this base angle. So if we see the example, if horizontal sextant angle is 32 degrees, then we do 90 minus 32 and angle that is 58. Bravo is equal to 58. So we'll plot 58 degrees from here and we draw an arc. We'll draw 58 degrees from here. We will draw an arc, and wherever they will cut, that will be our point C, center of the circle. From this C, we will take C and this lighthouse as this radius, and we will draw the circle. So let's see uh, the example how we do it. So in the question, we will be given horizontal sextant angle is equals to 32. We don't know where the ship is, and this will be compass bearing, so we cannot plot the bearing directly also. We just know horizontal sextant angle is 32, or if we are given the bearings, we subtract the bearings and we get the horizontal sextant angle as 32. Now we subtract this from 90, so 90 minus 32 is 58. It is from lighthouse 1 and 2, so this is our lighthouse 1 and this is our lighthouse 2. We join the lighthouses and we take this arc, we measure from the protector this 58 degrees, and same here we measure 58 degrees. Once we measure these two angles, we make the line and join them, and after joining, wherever they meet, that is our point C, that is the center of our circle, and we take C, and from the lighthouse, that is our radius. You can take this one on this one because both are equal. So this is our radius, and taking this radius from putting the compass center point as center of this point C, we draw a circle, and that will be our position circle. So this is our position circle of the first horizontal sextant angle, and same way we will draw a position circle from the second sextant angle, and wherever they cut, suppose this is the cut, so that will be our fix. So because of this principle may not be exact, that angle at the center twice alpha from this angle at the circumference. So you might not get the exact center of the circle. So this once you're making the circle, it might not pass exactly from the center of the lighthouses. So little bit you might have to adjust, and this way we can attend the horizontal sextant angle problems. Now to understand the horizontal sextant angle, how do we measure the horizontal sextant angle between these lighthouse? That's a different chapter, and that is not required here. Basically same like vertical sextant angle, we just hold the sextant horizontally and we take the image from lighthouse 1 to lighthouse 2 and we measure the angle. Otherwise we can do it from the bearings, but from the practical point of view or the chart work point of view, we are not required to understand how do we actually measure the sextant angle. That is a different chapter we can do separately.